Hi guys, we're now going to look at collecting like terms. Collecting like terms can also be referred to as algebraic simplification. It is the process of bringing like terms together in an expression. This is a very important skill that we use across all of the National 5 course, so you need to be comfortable carrying it out. First of all, what I want to do is I want to make sure we're all on the same page with what a like term is. Like terms that contain the same variables raised to the same power. Okay. Make sure when you're copying this down that you also include this definition so that you've got it to look back on. Okay, let's look at some examples then. Number 1, I've got A plus A plus A plus A. I'm happy that they are all like terms. They are all A. They're all of the same power. So I can go ahead and I can add them together. If I've got A and I add another A, that's going to give me 2A. Add another A on, gives me 3A. And then add one more A. So that's going to give me 4A. Okay, let's have a look at number 2 then. We've got 3C plus 2C. Remember, this is just adding up how many letters that you have that are the same. So we're looking for how many of the like terms that we have. I've got 3C, and I'm going to add on another 2C. So that's going to give me 5C. In number 3, we've got 8y subtract 3y. Slightly different. We're not adding things on, we're taking away. But it's the exact same principle. If I've got 8y and I take 3 of them away, then I'm left with 5y. For number 4, it looks slightly different again. I've got xy plus 4xy. However, I am confident that these are like terms because the x and the y are stuck together. So I'm taking my xy. If I add another 4 of them on, then that's going to be 5xy. So no change there. For number 5, we've got 5c plus 5c subtract 12c. And this is where another one of everybody's favourites may come into play with negative numbers. I'm going to split this up a wee bit, and first of all, I'm going to think of what is 5c plus 5c. That's going to give me 10c. And then I've got 10c subtract 12c. Well, if I think of what's 10 take away 12, that goes to negative 2. So my answer for this is going to be negative 2c. So keep that in mind. You can have negative numbers when dealing with algebra. For number 6, we have 2a plus 3b plus a. So I'm quite happy here that a and b are different. Okay, different letters of the alphabet. So if I'm collecting my like terms, I'm not going to bring the a's and the b's together. What I'm going to look for is, though, if I've got like terms in my expression, I'm going to deal with it alphabetically. So the first thing I'm going to do is I'm going to bring my like terms together. I'm going to start with the a's. I've got 2a plus an a. Well, that's going to give me 3a. Separately, I'm going to deal with the b's. I've got 3b, nothing else. So I'm going to put 3b on at the end. And that is me collected the like terms for that one. Instead of it being 2a plus 3b plus a, this is where the simplification comes in. That's the same as 3a plus 3b. If we take a look at example 7, I've got x squared plus x squared. This is where it's very important to remember that definition that we had at the very start. Like terms are terms that contain the same variables raised to the same power. Now, even though we've got x squared and x, they have got the same letter. However, the squared is the power. And what that does is that creates x squared as a different term from just x itself. So I'm going to deal with this in pretty much the same way that I dealt with example 6. I'm going to deal with the x squared terms first. I'm going to deal with the highest power first. So I've got an x squared, and then I'm adding on another x squared. So that's going to give me 2x squared. And at the end of that, I'm going to add in x on its own. So what we'll get from that, simplified x squared plus x squared is going to give me 2x squared plus x. I wouldn't take that any further. I would leave it like that. Finally, for example 8, we have got 2y squared plus 4y squared plus 5y plus 9. I'm not going to change anything about the process that I use here. I'm going to deal with all the different terms and I'm going to collect them together if they are like. So I've got y squared is going to be a term, y is going to be a term, and then this 9 stuck on at the end, it's just a number, it's not got a letter attached to it, so that's going to be separate as well. We know that we deal with the highest power first, so the first thing that I'm going to deal with is the y squared term. I've got 2y squared plus 4y squared, so that's going to give me 6y squared. I've then got my 5y, and then at the very end, I'm not going to leave it out, I'm going to put in the 9 as well. What we've done there is we've simplified 2y squared plus 4y squared plus 5y plus 9 into 6y squared plus 5y plus 9. Okay guys, that is us covered collecting like terms. This is Mr. Gillen signing off. Speak to you all soon.